Welcome back to the deep dive. So many of you have asked for a roadmap. You want a real, actionable path to get into a new technical career, but, without all the noise of the internet. You want the cheat sheet.
And I think we found the ultimate cheat sheet. We've got our hands on this really detailed job plan from 2025. It's a source that gives a massive shortcut.
And this isn't theoretical stuff.
Not at all. It's a specific 3-month easy learning plan. It's designed to take you from knowing, well, almost nothing about operations to being immediately useful in an entry-level tech role.
So that's our mission for this deep dive, to really unpack that 3-month structure week by week. The advantage here, it seems, is that it doesn't just list a bunch of tools, it connects them.
That's the key. It connects Linux, networking, automation, delivery, all into a single, coherent, modern workflow.
It's about the strategic prioritization then.
Exactly. In these fields, your time is the most precious resource you have, so knowing which 8 skills to master first, and crucially how they build on each other, well, that's the blueprint for getting ahead, fast.
Okay, let's unpack that foundational list. Before we get into the monthly breakdown, let's just establish the terrain. What are these top 8 essential skills this plan says are, non-negotiable?
Right, so the list is rooted entirely in modern infrastructure. The foundation starts pretty predictably with Linux administration.
Okay.
And it specifically mentions both the stability of Red Hat and, the user-friendliness of Ubuntu. You just have to know how to get around an OS without a mouse.
The command line is still king. You absolutely cannot skip that.
You can't. And right after that, because doing everything manually gets tedious really fast, is shell scripting, specifically Bash. This is your first real taste of automation.
So moving from just reacting to problems to actually programming solutions for them.
Precisely.
So we have the OS, and we have that first layer of automation. What bridges the gap to make these systems actually work together in the real world?
Communication. Skills 3 and 4 are networking basics, so DNS, firewalls, routing fundamentals, and monitoring tools. The plan names Zabbix and Grafana.
So you need to know how systems talk to each other.
And you need to see when they stop talking correctly.
Yeah. And now we're getting into what feels like the modern standard for application delivery, moving beyond just one server.
That brings us to Docker and containerization, which is, frankly, non-negotiable today. Then we layer on automation with basic Ansible automation. And finally, Skills 7 and 8 cover the whole workflow, CI/CD and Git basics, mentioning tools like Jenkins and GitHub Actions.
Now, I did notice in the source material, the plan listed a conditional 8th skill. Can you clarify that for us?
Yes, the plan includes Java basics and JVM tuning, but, and this is a really critical footnote, it says you should pursue this only if you're targeting a role that specifically supports Java applications.
So if you're going for general infrastructure or a DevOps role, that time is better spent somewhere else.
Much better spent solidifying the other 7 skills. Knowing what to skip is a really powerful form of prioritization.
That one insight could save someone weeks of effort. So if you look at this whole group OS, networking, automation, delivery, it's basically the entire modern stack you need.
It is. You're learning how to build and operate, not just how to code or how to click a button.
All right, let's dive into the timeline. Month 1, Foundation in Linux and Scripting. This seems like where the real commitment is, getting comfortable in that command line environment.
The first 2 weeks, so week 1 and 2, are all about Linux basics. The first step is immediate. Install Ubuntu, preferably in something like VirtualBox. You need a safe place to break things.
And we're trying to achieve more than just knowing Ls and CD, right? Because anyone can memorize a few commands.
Right. We're looking for true administrative competence. You have to master file manipulation-P, MV and permission control, chmod, chown, and of course privilege elevation with sudo. But the real secret is understanding the file system hierarchy.
That's the operational context, knowing the difference between etc. and var.
Exactly. Knowing config files live in etc. and that logs are in var is just fundamental. If you don't really get user management and file permissions, you'll spend your whole career debugging weird access issues.
A good warning there.
And a quick tip. Never, ever use kernel chen 777 just to make an error go away. That is a security failure just waiting to happen.
A great real-world caution. Okay, so once that foundation is solid, we move in week 3 and 4 to shell scripting.
We transition from being a user to being, well, a programmer. Bash scripting is essential because it's just It's on every Linux system. The goal is to write simple, repeatable programs using variables, loops, and some basic if-else logic.
And the practical application has to solve a real problem, I assume.
Yes. The plan suggests automating something like file backups or cleaning up old logs. These are tasks that, when you do them by hand, are tedious and you're bound to make a mistake.
So by automating them, you immediately prove the value of what you just learned.
You do. It's all about error reduction and efficiency. This is the skill that lets you move on to the more advanced automation tools later with confidence.
Okay, so month 1 gets you navigating, administering, and doing basic automation on a single server. That sets us up for the big jump in month 2. Networking, Docker, and monitoring. This is where things start to connect.
Week 1 is all about that connective tissue, networking fundamentals. We need to get clear on core concepts like IP addressing, what DNS actually does, how names turn into numbers, and DHCP, which hands out those numbers automatically.
And on the practical side, how do we practice this?
You need to start using tools, ping to see if you can reach another machine, netstat to see what ports are listening on your system, and you have to understand firewalls and ports. If you can't define what a firewall does, you can't deploy anything securely.
Okay.
The source mentions Cisco Packet Tracer or just some basic CompTIA network plus material as a great place to start.
So once our systems are talking to each other, the next challenge is packaging our applications cleanly. And that means week 2, Docker and Portainer.
This is a huge fundamental skill shift. You need to understand containers versus virtual machines, the difference between an image and a running container, and how you manage data with volumes. And, crucially, you need to learn Docker Compose.
Why is Docker Compose so important for a beginner?
Because almost no modern app is just one container anymore. You'll have a web server, a database, maybe a cache. That's 3 different containers.
Right.
Docker Compose lets you define and run that whole multi-container application with a single YAML file. It's so much simpler than running 3 different long commands.
And the plan mentions a helpful shortcut for learners.
Yeah.
Portainer.
Yeah, Portainer gives you a graphical interface. And look, while we stress the command line, Portainer is invaluable here because it helps you visualize what's going on. You can see resource use, network connections, container health, things that are totally invisible in a wall of text. It just speeds up learning so much.
Week 3 then tackles the other side of deployment, visibility. With monitoring tools, how do we structure learning Zabbix, Grafana, and Prometheus? That sounds like a lot for 1 week.
It is a dense week, but it's manageable if you understand their roles. Think of it like a 3-piece band. Zabbix is the agent. It collects the data from your system. Prometheus is like the specialized database. It stores all that data efficiently.
And Grafana.
Grafana is the lead singer. It takes all that data and visualizes it on these beautiful dashboards.
So you're not really learning 3 separate systems. You're learning 3 parts of a single stack.
Exactly. The goal for the week is to install Zabbix, have it pull some Linux metrics, and then build your first dashboard in Grafana using Prometheus as the data source. You're moving from asking, is the server on, to how is the server performing?
And month 2 wraps up with practical synthesis in week 4 mini projects, forcing that immediate integration.
The plan requires 2. First, monitor your own Linux system with Zabbix and Grafana. Second, set up a Docker container running an Apache web server and monitor that.
So you're confirming competence across the OS, networking, containers, and visibility. You're not theoretical anymore.
You are operational.
That operational competence leads us right into the final month. Month 3, automation, CI/CD, and final synthesis. This is where we learn how to scale and deploy everything automatically.
Week 1 is all about Ansible basics. This is your introduction to infrastructure as code, or IAC. You have to master YAML, which is the language of Ansible playbooks.
Why Ansible? Why is that the first IAC tool here and not something like Terraform or Chef?
Simplicity. Ansible is agentless. It just uses SSH, which makes the setup really easy. And YAML, while it can be a bit tedious, is very human-readable. It's an ideal gateway for a beginner.
So a much gentler learning curve.
Much. The goal is just to write some simple Ansible scripts to install a package or start a service on a few virtual machines.
And I see they recommend Vagrant as an optional practice tool here.
Vagrant is fantastic for this. It lets you define and spin up disposable virtual environments really quickly to test your Ansible scripts. You can break everything, fix your script, and then just rebuild cleanly. It really solidifies that automation mindset.
Week 2 shifts to that final layer of delivery, Git and CI/CD basics.
Right. You start with Git fundamentals. Clone, commit, push, pull, how to manage a remote repo on GitHub. Then you move into CI/CD, continuous integration, and continuous deployment.
Can we just clarify what CI/CD means in practical terms for someone listening?
Of course. CI, continuous integration, is the automated process of building and testing your code every time a change is committed. CD, continuous deployment, is taking that validated build and automatically deploying it somewhere. The point is to focus on Jenkins or GitHub Actions basics, setting up those automated steps so humans are no longer in the loop running manual commands.
And week 3 is for that optional track Java basics and JVM.
Again, only if you're targeting those Java-heavy roles. The deep dive here is narrow. Understand basic Java syntax, but more importantly for an ops person, get a grasp on JVM tuning. This means understanding flags like Natchez XX and Nash XMs.
And what do those flags actually do?
They set the maximum and initial memory for the Java application. For someone in operations, this is critical because it directly links the infrastructure, the memory on the host machine, with the application stability. If you don't tune the JVM, the app might crash, and you're the one who has to fix it.
That connects the software right back to the OS, which brings us full circle to the big crescendo in week 4, the final capstone project. This is the ultimate test.
It's the total synthesis. The complexity is high here.
Right.
You have to create a full CI/CD pipeline. It has to pull code from GitHub, automatically build a Docker image, deploy that image to a container, and then monitor the health of that container with Grafana or Zabbix.
A project like that shows you don't just know the individual tools, but you understand the entire life cycle of modern software delivery, from code commit to a live monitored service.
If you can do that final project, you have achieved the entry-level competence you need. You can step into a junior role and immediately contribute in an automated environment.
Let's just quickly summarize the sheer breadth of what someone achieves after this plan.
The portfolio is strong. You master Linux, so Ubuntu, Bash, services. You have scripting and automation with Bash and Ansible, networking. DNS, IP, firewalls, monitoring, Zabbix, Grafana, Prometheus, containers, Docker, Docker Compose, Portainer, and of course CI/CD, Git in Jenkins or GitHub Actions.
And the best part is, the source material removes that financial barrier to entry by saying exactly where you can practice, often for free.
Absolutely. The plan says use VirtualBox with Ubuntu server, Docker desktop, the free tiers on GitHub for your CI/CD. The whole lab is local and accessible. You just need time and focus.
So you now have the map, the resources, the weekly milestones. It turns this, overwhelming career shift into a structured series of sprints you can actually achieve.
What's really fascinating, though, is what the plan explicitly calls out as optional skills, things to learn after these 3 months.
Right. The source mentions virtualization, bonus VMware, vSphere, optional later, and programming, optional Python Go. This really forces a choice on where you specialize next.
So if this 3-month plan builds that foundation, what is the next most logical, highest value jump for you to make as a learner? Do you master virtualization like VMware vSphere, really solidifying that on-prem or hybrid infrastructure layer?
Or do you immediately integrate deeper programming languages like Python or go into your automation?
It's the crucial strategic decision. Do you double down on the infrastructure itself, or do you enhance your ability to create more powerful custom automation scripts?
It depends on whether you see your future self as more of a systems administrator or more of a true DevOps automation engineer.
And that's the research you, the learner, now have the context and the knowledge to actually go out and perform.
A perfect question to explore after mastering months 1, 2, and 3. Thank you for structuring this incredible deep dive for us.
My pleasure. Go forth and automate.